Hi guys, I'm Gabby. I work at White Ops, where we try to fight bots all the time on the internet. And even before joining them, I discovered that I was already doing it unwillingly or unknowingly, actually. Let's start with a few questions about you. It's okay. How many of you use Android? All right, represent. And how many of you are developers? Android developers? Android hackers? All right. So let's start by saying a few more words about me. I'm a hacker, an Android hacker. I like taking things apart and then hopefully putting them back together, including apps, systems, devices, whatever you name it. Follow me on Twitter for the latest memes and on GitHub for my latest projects, because there's going to be more to it. By the way, you can find the project that I'm going to be talking about on GitHub. I usually try to update it every few months with the latest fixes and whatnot. I started this whole affair with the cybersecurity world back like 5 years ago, when I hacked the MiFare cars that were being used by the public transportation system in Romania. Fortunately, the CERT guys were really kind to me, and they implemented my solution really fast. But unfortunately, I discovered that I couldn't travel freely around the city. So I decided I should hack my car. Now, I didn't make it work on air or anything like that, but I did discover that it had some pretty serious privacy leakage concerns. But moving forward, I discovered that my car was just a computer on 4 wheels, as are a lot of other devices that we use nowadays. We have smart TVs, we have smart fridges, we have smart toasters, smart cars, and even smarter toasters. And hopefully we won't get there anytime soon anyway. But this is starting to become a worrying trend. We put Android on more and more and more devices, just like a magical fix-everything solution. And 3 years ago, or 2 years ago, I can't recall exactly, Kevin Beaumont found a bunch of Android devices that had ADB open over the network. For whoever doesn't know what it is, ADB is basically a protocol that initially started as a developer's best friend, basically. You could push APKs, you could interact with your phone in a headless mode just from the command line, and it had absolutely no authentication. Now, Google fixed that, but they also added a pretty neat feature. You could enable ADB not only from your USB, but you could also do it via network. So you could just open a port on your device, and from now on, everybody could connect to that port and could use the device as a normal user could, mostly, for a lot of shady purposes, basically. So my goal would be to try to find out what kind of attacks are being launched against these kind of IoT devices, because they are getting more and more. I mean, there were like 80,000, and a lot of them were completely unprotected. So I just started digging around, trying to read about the protocol, trying to figure out how it worked, and just get a simple system that would accept a connection to it, a binary being pushed to it, and a shell command. And I started tinkering with it, just hammering away, trying various solutions, failing a lot, breaking my phone because turns out that having a phone with ADB enabled for every hacker to connect to wasn't that much of a clever idea. So the solution in my case would have been building a system from the ground up that would accommodate all of the three needs that I initially stated. So connection, shell commands, and binary uploads, the main three activities that you can do on ADB. And I started reading. Turns out there's quite a bit of documentation about it. The problem is that it's a bunch of text files inside Android's repository, and it sucks. And it's really outdated. Basically, ADB, as I said, started as a simple USB debugging protocol that somehow had a lot of features being bolted on as it progressed. Now, the community started pushing back on this. There's a lot of open source research that can be found on the internet. It's not that complete, but it still clears up some of the unknowns that I had. And just as a quick summary, an ADB packet is formed by the command, two arguments, data length, CRC, and some magic, because everybody likes magic. The commands are really simple: sync, connection, authentication, open, OK, close, and write. And if you try to put them together, you can get like a high-level overview about how the protocol works. For example, if you want to to list the files via an ADB shell command, just open the connection. Keep in mind that this is the traffic that we're really interested in. This is locally, and this is running on the device. So we send a few commands to the ADB server running on our host, and the server connects to the ADB daemon. And you just have to send an open packet with the shell command, and then you're going to get your result back as a write packet that has the contents of the shell command that you wanted to execute. And it didn't work, and it made my cat angry as well. Somehow I was missing something, even though I respected the protocol like textbook. The problem being that this is not a typical CRC32. This is completely undocumented about why it's like this. And after the ADB packet, somebody bolted on a whole other sub-packet that it uses in executing more complex statements. Like, for example, when you try to push a binary, you've got a lot of control data that's being passed around in this sub-packet. The reason being, I don't know why. It's something that has been decided at some point, and there's zero documentation about it. Now, fortunately, I had a lot of free time at my disposal, so I started capturing traffic for every type of flow that I was going to implement. You would think that these are three commands, like separate commands that would be issued. No, this is a simple ADB push, and depending on the quality of the network that you are working on, it's gonna have one of these three flows. The slides are gonna be available after the presentation. I'm just gonna leave here all of the data that I've gathered. But the idea is that there was no consistency whatsoever. These were the three main flows, like statistically speaking, when trying to push a binary. The best thing that I could do was just assume that this was magic, aliens, whatever, and reconstruct those flows using the tools that I would find available. Fortunately enough, there was somebody who already did most of the heavy lifting when it came to building and reconstructing the packages. He was kind enough to allow me to use the code for this project, and I started digging in, started hammering away, trying to implement all of the flows, trying to get as many binaries being pushed while testing it and failing, like having a really low failure rate, because we're not interested in catching 100% of the attacks. We only wanted to catch 90% of the attacks with 10% of the work that would be done. And it worked. It was quite a descent into madness. I had to just, in the end, I abandoned all the resemblance of logic and just kept a list of commands that I would receive. Match just had a long piece of paper where I would have all of my notes, like when I see this sequence of packets, I have to reply like this. When I have this other sequence of packets, I have to reply this other way. And it worked. It was a lot of spaghetti code. It's not the most elegant work that I've done, but in the end, I managed to have a fake device that I could put anywhere on the internet, even on my own phone, and get ADB commands and reply to them as well. One of the problems that I encountered, and it should be like something to look out for if you try to do any kind of protocol analysis, is that corporate firewalls have a lot of problems with protocols such as ADB in our case. I think I lost about a week trying to figure out why my honeypot only worked for the first 5 packets. Turned out that the honeypot worked without a scratch, but the corporate firewall was dropping everything else for a protocol that's legitimate. I do not know what are the issues right now for the honeypot. I do know that it catches malware, and we're going to talk about that in just 1 minute. If you want, you can just connect to it and issue whatever commands you want. Just give me a shout, say hi, whatever. And now to the juicy part. Let's look at all of the malware that I caught while leaving this honeypot to run for about 1 year, 1.5 years. This was the most the first interesting guy that I stumbled into. He pushed one of these shell files, and it would look like, wow, this guy is like a white hat researcher trying to protect the internet and just remove all of the malware that other guys would install. Well, no. He just pushes his own miner. He basically used an APK that had a web page embedded inside, and the web page would run a JavaScript that did mining, basically using the old coin hive trick. A really interesting piece of work was something called Trinity, and a more complex write-up is available on the internet on my previous company's blog. Trinity is basically a worm that mines on Android devices. And it does that using the same trick as our Good Samaritan before. It pushes an APK, and the APK loads an HTML file, and inside the HTML file, boom, coin hive, of course. Now, the neat trick is that there wasn't only one file being pushed to my device. There were a couple of them, one being the APK, and the other 2 being the components of the worming part. So it was a binary that would just scan the internet And whenever it found a device with the port 5555 open, it would push itself together with the binary and the mining APK to the vulnerable device. Needless to say, it escalated really quickly, and I think there were like 1,000 IPs at one point, all mining and doing work for the Trinity guy. But fortunately, here comes another actor called FBot. And FBot was really cool because the FBot script also tried to uninstall Trinity. So you have like a whole dog-eat-dog situation when it comes to this kind of botnets being like a limited resource. You only have, I mean, at its peak, there were 80,000 IPs. Nowadays, there's a lot less, thanks to the joint efforts of other fellow security researchers. FBot was the first one that got into the media highlight by the guys at 360. And of course, it uninstalls Trinity's miner. It doesn't remove it all the way. It only uninstalls the APK in order to trick another worm from preventing infection, because the worm is going to look and see if Trinity is running, and if Trinity is running, then it won't infect the device anymore. So this one is only installing the miner. And 1 month after, the guys making Trinity realized this, so they added even more checks in order to push the miner if it wasn't running. And this started getting into media. There was a lot of coverage about guys fighting over the scarcity of exploitable Android phones or TVs or fridges or whatever. And as soon as the media coverage started and the AV vendors started flagging ADB as being the Trinity and FBot as being malicious, traffic started going down. But the problem is that the devices were still there. Nobody tried to actually close them down. And you've still got guys like this one trying to send a big payload because turns out he just finished his OSCP training over the wire, and he did that from one single CNC. Fortunately, the community responded pretty fast, and all of these guys got shut down instantly. I mean, I would see them spamming my honeypot for a day, and the next day, somebody would send an abuse complaint and shut them down. We've got Putin's little helper right here. It's a Dvr malware that propagates itself from a central CNC and mines, because this seems to be a quite profitable activity for bad guys. But the funniest one was the apologetic miner. So I found this guy at some point. And he says he's sorry, but because he's mining on your device, he doesn't have a job. And if you're going to send him a mail, he's going to put your device on a whitelist and not infect you ever again. Unfortunately for him, he got shut down as well. So I guess he had to resort to a different way of funding his adventures on the internet. Now, in the aftermath of my little project, the amount of devices vulnerable dropped from 50,000 to roughly 10,000 nowadays. And a few months ago, I said, all right, so if the device count went down, then why am I seeing more traffic into my honeypot? Because that was actually happening. I would see more shell commands being issued, more binaries being pushed, the amount of connections would remain quite the same. And if we plotted this by quarter, because unfortunately I didn't have really exact telemetry for the project, you can see that the number of shell commands skyrocketed in the last 6 months, while the number of unique IPs and binary uploads confirmed what I saw while guesstimating the impact. And if we zoom in on the last 2 quarters, you can see that there was a big spike in July of just shell commands. So somebody found out about the attack, and of course that they started mining on the device. The IP got a lot of abuse complaints, and his whole operation was shut down quite fast, so it only took like 1 month. Actually, fortunately, if nobody would have made an attack, a honeypot to detect attacks like these, you couldn't have blocked this guy. I mean, there was no visibility when it came to worms that worked on this port whatsoever before we had that paper from Kevin and before having the honeypot. And the security community reacted in such a cool way about this. I started getting bugs, and I usually get really mad when people submit bugs to me, but those were really cool features and really cool bugs that could be fixed and got fixed by fellow security researchers in their free time. So everybody just tried, basically gave their time to this project, and we got it into Teapot. And as soon as it got into Teapot, the number of attacks dropped like on an exponential basis. So I don't know, guys. I guess that this illustrates that when there's a will, there's a way on both sides. So as long as the bad guys are pushing the limit, all we have to do is just push back as a community and make the internet better. Thank you. And if you have any questions, feel free to ask.
So usually when you talk about your research, and obviously the bad guys are watching that as well, how do you know that the attacks decreased and not, for example, that they are now able to identify that it's a honeypot, so they don't attack you, but they keep attacking regular people?
Well, the honeypot that I was running was providing me more of a rough estimation anyway, because it was in a residential. It wasn't in a residential IP space. It was in a data center. But I was cycling the vendor ID for the honeypot periodically. In this way, you can't identify what kind of device it is, if it's a honeypot, if you've only got one port open, and you're a Linux machine as well. So I don't think that they detected the honeypot. But I've noticed that if you go on Twitter and you look for people submitting and trying to verify abuse complaints, they increased like a lot more after releasing the honeypot. So the community was really active in trying to stop this threat.
So there's one more question.
Hey, Gabriel. Congratulations for the talk. Really interesting. And congratulations again, because it's really cool to see how Kevin highlighted an ADB problem, an ADB problem outside, and you decided to create a tool like that for the community. So congratulations for that. I have 2 questions. One question is, can you tell more about, because it's quite common to delete competitors when a bad guy tries to infect a system and tries to detect more people infecting that system, deletes other malware and install their own malware. Can you tell more about how many times you detected that? If it's like a common stuff, or it's just only a few campaigns or few families that were deleting competitors and their own malware?
So the biggest offenders were FBot and Trinity. When it came to, they did their research and they knew the competition, so they deleted everything in one fell swoop. For other strains of malware, it's more like a fire and forget methods. They just do a mass scan before that, and then from a random data center, they just push the ADB shell commands, and they push their bot, and that's that. They don't do anything more.
Okay, thank you. And the second question is, did you have plans for ADB Honeypot? Do you have plans to integrate in other open source project or be part of a major framework? Because we had an interesting conversation yesterday. Maybe you can tell something to the audience.
Yeah, unfortunately, ADBHoney is being built in my free time. So I'm trying to use as many spare cycles as I can to make it move forward. I will be trying to push it to more platforms, but after I finish the Python 3 conversion. It's 99% done. Right now, I'm just verifying that it works and I don't have any more bugs. But it should be Python 3 ready by the end of the week.
There's another one.
So thank you for the talk. Couple of clarifications from guy who used to develop things like that from the USB side. So a brief history of ADB is that the goal why the protocol has been created was to transfer multiple streams over to USB endpoints. And basically ADB in the beginning was all about that. And the things that are being transmitted over the protocol, they are totally independent. So you know that ADB has this abstraction of streams.
Yeah.
So whenever you open, you get 2 IDs, and that's basically your stream. And then whatever is on the other side is just the process that ADB starts and run on one of those sites. So my first question is, what's the reason of just not reusing the ADB that you can find in Google source code? Because what you could do is just simply strip all the commands that are being executed by ADB and use the whole protocol implementation.
That was my original idea as well, but I suck at C.
Okay. So I can tell you that I'm not sure how many cycles have you put into that, but I expect that taking out this daemon and just adding your own targets instead of developing everything from scratch would be maybe a day of work.
If you knew C.
Yes, yes. So that's the first comment. The second one is, where is the ADB authentication?
I'm simulating the device, so I'm not asking for any authentication.
Okay, but then I believe that it would be really interesting how the malware is trying to deal with ADB authentication. Because you should have the challenge response, right? This is how typical modern ADB implementation works.
Yeah, yeah. So it works with every ADB, like all of the modern ADB implementations, because if I send, so when they connect to me, I just send them the "you're authenticated, everything is okay" command,
Yes.
and it works.
Yes.
Yeah. And I don't think that the malware guys have recompiled their own ADB client by, I mean, just look at the code.
Yeah.
Yeah.
So I'm not saying that they recompiled anything. I'm just curious what methods they are using to bypass the authentication, because I know at least a couple of them. So I expect that they are also using that. So I believe that this may be a nice addition to the research.
Yeah.
Not only the payloads that they are using after they manage to get in, but also what methods they are using to actually get into the system.
I have a bottle of Soplica that's waiting for you. Let's have a chat after.
Thank you.
So thank you, Gabriel, for presentation.